This is a 3D printed RC log truck equipped with a fully functioning loader arm, meaning once you've pulled up to your log landing, you can switch the model from truck mode to loader mode, unfold the arm, and use it to unload the pup, which is connected via this folded sliding reach. The arm possesses all the crucial functions required to load logs, or sticks in my case, such as this rotating grapple, which is essential in being able to maneuver and settle logs into place. Once everything is loaded, folded, and switched back to truck mode, you can then haul the logs just like you'd haul anything else. After delivering the load, you can then of course self-load the pup back up onto the truck to prevent any unnecessary wear and tear. Now if the whole stick loading thing isn't for you, you can just forgo the log bunks and keep the standard fifth wheel, letting you hook up to all ranges of trailers, such as this side dump, and then use the arm as a personal loading machine for picking up living room messes or clearing your front sidewalk after a windstorm. So before I'd actually committed to the self-loading log truck, this project started out as just a standard log trailer that could be hitched to with a traditional fifth wheel. This of course all went out the window when I asked my brother what he thought of it, in which he responded, lame. So lame. I dare say he even said we call that a hay rack, not a log trailer. After my initial urge of setting him straight dissipated, I was of course devastated and faced a quarter-life crisis on what I'm even doing. Ultimately though, I responded with a frowny face and then proceeded to spend the next 60 hours of my life drawing up CAD designs for a self-loading log truck. I'm talking about a bunk that swivels instead of a fifth wheel, a folding reach mechanism, the arm, little bars for the tires to sit on. It's all actually a bit of a blur. My biggest design consideration while building out each part was that any self-loading aspects of this log truck need to be applicable to any pre-existing semis that people have. Meaning, if you've already built the traditional semi for hauling trailers and want to convert it to a log truck, you can just by printing out these log truck specific parts and smacking them directly onto the semi without having to reprint any of the core pieces. I just want to touch on the build photos you just saw and briefly say this little RC community that's developed is awesome. It is super cool to see what you all have done with this. I mean, this Optimus Prime spin-off of the truck, 10 out of 10. Or this railroad version of the RC excavator. But one of my personal favorites right now is this base station idea developed by Garvey, which essentially lets you swap control between models via one controller and just by the press of a button. Meaning as a one-man show, you can operate multiple machines all at the same time. This is exactly why I love building these like little robotics projects, as it gives you, the builder, full control over the software, and if you want, you can go full developer mode, letting you make changes to do awesome stuff like this. Now, all of that aside, I also want to briefly give a thank you to everybody who came by the booth at OpenSauce. It was super awesome meeting some of you in real life and hearing about your own creations. OpenSauce just attracts the creme de la crop of people, and I seriously can't recommend it enough. William Osborne knocked it out of the park. But anyways, that's enough of that. Back to the log truck. I designed the bunk swivel to mount where the fifth wheel did, and then the base of the self-loader to mount where the electronics cover went. To really highlight this, I've decided to convert my golden semi into the first log truck.
Some of you may die, but it's a sacrifice I am willing to make.
I first removed the sleeper, which to actually do this properly, you'd want to use a day cab that doesn't have this pass-through on the back. But I'm going to worry about that later, as I've already got plans to reprint it in a different color anyway. Before mounting anything, I removed the fifth wheel as well as removed the magnetic hitch connector, which on the bright side significantly simplified the wiring. I chose to leave the hitch servo in place for the time being, just in case I ever convert it back to a truck for hauling any of the trailers, though I did unplug it to free up a servo slot. In my opinion, what will end up being one of the most crucial parts in determining the overall success and usability of this log loader will be the base piece and how stable / smooth it is. For the swivel as well as the log bunks, I went with these 37mm bearings, which a pack of 10 can be found for about 13 bucks. The fitment on my first couple iterations was not great, as there was a gap between the inner bearing sleeve and the 3D printed part, meaning friction alone was definitely not going to hold this on, at least for this iteration. Preferably, I'd like these to be pressure fitted using a mallet that taps the bearing bearing into place, but for now I temporarily held them with some hot glue so I could test the other parts. One of the best things to do while prototyping is to keep a notepad handy for writing down all the small issues you find during assembly, because if you're anything like me, by the time you get back to the computer to implement changes, you'll have forgotten 2 out of 3 things to fix, which means you'll print a whole nother round of parts just to face the same issues. A nice laid out grocery list of items to fix though, and you'll be good to go. The arm came together pretty smoothly for being a prototype, and after dry fitting it, I have faith it'll be able to reach a fair distance, definitely far enough to pick up a log and put it in the trailer. Side note, these little mud flap hanger combos turned out absolutely awesome. I'm not sure why I like them so much, I just do. One of the biggest concerns dating back to my first mental image of this self-loader was how to actually get enough power to the base of the loader arm for it to be strong enough to lift up a stick. The overall reach of this arm is greater than that of my excavator, meaning it will need more power to exert the same amount of lifting torque at the end of the arm. I don't believe I have this first design fully optimized, but I ended up putting the motor in anyway and hooking it up to the power bench just to see what this could potentially be capable of. This is a 1000 RPM threaded N20 motor, and honestly, it did really well. Definitely well enough to pick up some sticks. Before testing anything via my PlayStation controller, I did have to break out my laptop and update the original truck code to include controls for the loader arm as well as wire it for actual use and put it in the truck. At first, it seemed all of my controls were laid out in random order, and only after an hour spent in smooth brain mode did I start investigating the right system, which is where I found out that I had mislabeled some of my motor outputs, so what I thought were the outputs for the arm rotation were actually the grapple and vice versa. Luckily, this is as simple as flipping 4 numbers. Ultimately, I chose to lay the controls out like so. To switch from truck mode, where you can drive around like normal, to loader mode, which transitions the joysticks from throttle and steering to arm controls, just press down on the left joystick until it clicks. The swing left/right motion is set to left and right on the left joystick. Main boom is up and down on the right joystick, dipper is up, down on the left joystick, grapple rotation is set to left and right on the right joystick, and finally claw open and close is set to triangle and X. If you lost track of all of that, here's a diagram. Minus grapple rotation, this setup mirrors my excavator ISO controls. Plus, when it's all done, it folds up all nice and neat above the cab. Not bad at all. The second part of this build is the pup, which carries the other bunk that holds the logs in. I chose to just copy and paste almost the exact same bunk swivel design as the truck over to simplify things. Moving on, there's a couple different ways to have a pup that can be self-loaded, but for my purposes, I opted to go with this folding reach design, which, as the name implies, can be folded up on itself, allowing the pup to slide up onto the truck. This folding design was a huge win for multiple reasons, as I was concerned I'd have to figure out how to hitch the pup to the truck, which would mean figuring out a new way to transmit power and information via a hitch connection, which, as we saw in the original truck design, was hard enough with the fifth wheel, where I had way more room to work with above the axles in comparison to the could have been hitching system found on a log truck, which is more just like a shackle. The folding reach will allow me to just loop a set of wires between it and the truck, which can then be used to send power to the blinkers or servos if there needs to be one. I went through a ton of iterations to get the folding bunk just right, or at least right enough to work with the log loader. I've still got some tweaks to make before it's fully finished, but before going further, I do want to touch on the second reason why having this fully attached folding pup is a big win. The reason is static electricity. This is something I didn't showcase in my original truck video, primarily because I only noticed it after I started filming. Since then, I've had numerous people ask me about this seamlessly useless wire I'm having them install on the hitch assembly step of the truck how-to guide. The wire runs from the ground terminal block down to the axles where it's splayed open and can contact the ground. The reason for this wire is to dissipate static electricity buildup. You see, as the truck drives around, it's generating static which builds up in the plastics and electronics of the truck. This becomes a big deal when you go to hitch to a trailer which has its own charge that is much lower than the truck because it's just been sitting there. So as the truck comes in and hitches, all that static electricity discharges from the truck to the trailer, effectively tanking the truck's voltage for just enough time that the ESP32 blips off, aka browns out, and loses connection, at which point you have to re-pair to the truck. If you're just driving on hard flooring, you'll never notice it as the buildup is small enough it dissipates naturally just on its own. Even if you're on some types of carpet, you might not even notice it. The only place I have it happen is on the carpet of my filming space, and I still just don't really know why. I just know that the grounding wire is what officially fixed it. I tried remedying this in other ways, like using a big old capacitor on the ESP32 power and ground to smooth out voltage fluctuations, which helped a little bit but wasn't a total fix. I tried a TVS diode, which is specifically meant to help with static. That still didn't fix it completely. The only thing that did was having this wire dangled down. So chances are you can get away with not having this wire and be okay, but if you ever start to notice it shutting off when you hitch, just add this small length of wire down to the ground and you'll be good to go. Out of all the people who have built the RC Semi, not one has messaged me saying they've encountered this same static problem. I genuinely think it's something about the carpet in my filming space and how the building I'm in is constructed. As just walking 10 feet across the room, I'll shock myself when I touch a 3D printer. Though at my home, which has much thicker carpet, I drive an RC truck with no ground wire and I've never once had a problem with it disconnecting. That said, I still thought it important to touch on this just in case any of you have a similar problem on a project in the future, as I spent a significant amount of time banging my head off walls trying to figure out what the heck was going on and why I couldn't recreate this issue anywhere else. All of that was to explain why having this fully connected pup is a win, as everything will just build static together and we don't have to worry about any sudden discharges when hitching. Now that that explanation is out of the way, we can move on. I performed a small unloading test to make sure everything balanced properly. I also then tried picking up this solid piece of dowel, which despite my worries on not having enough power, it actually managed to do it. This is great because I doubt anybody will be picking up stuff much bigger than this, and also anything much bigger and the claw will start having trouble properly grasping it. Before testing this out fully, I do need to take care of something that's been seriously limiting me since the creation of the truck, which is this display table. I originally built it with the excavators, skid steers, and forklifts in mind, which it works great for, but when I plop a semi down onto it, well, I can go from one end to the other in about 3 seconds flat, and don't even get me started on turning a trailer around, especially when there's stuff in the way. The only sensible thing to do is make the table bigger, which is exactly what I did. I added on a roughly 6 by 4 foot section, painted it, and started tearing cardboard apart to create a mountain. If you've ever wondered how to create diorama mountains for your own RC creations, I'm about to give you the Spark Notes version, which all starts with some good old trash. Simply heap it up into your desired shape. Then my personal favorite thing to use after you've built up the bones is torn apart pieces of foam, as it gives natural looking curves and edges. Once you've got the rough shape, it's time for plaster cloth, which can be found at most, if not all, hobby stores. Just dip it in water and lay it over your mound of trash, one piece at a time, with a little overlap until it's fully covered. Once it dries, get yourself a whole heap of wood glue as well as a paintbrush and start laying it on. The goal is to fill all the small plaster cloth holes. This step is really what sets a good diorama mountain apart from a not so great one. When the glue dries, it may still look like there's holes, but it's likely the glue is just really thin and transparent in that spot. You won't really know till you hit it with your first coat of spray paint, which I like to start by just coating the whole thing in gray to simulate a rock base layer. For this mountain, I wanted to make it a little bit of an excavator obstacle course, hence the Mario map looking overhang style. To really drive this home, I laid down the glue in the shape of tracks/ruts and sprinkled dirt and small rocks over the top. Whatever didn't get attached to the glue, I just vacuumed up after the fact. Next is grass, which is where stuff really starts to come alive. Thanks to my uncle, I got my hands on one of these electrostatic shakers, which makes a huge difference as the static electricity causes the grass to stand straight up when placed rather than falling flat. After the grass is added, in order to get a bit more depth, I like to add bushes anywhere it looks like water might accumulate, as well as little plants. So that would be little V's in the rock or ledges. Vines work great in tight corners to break up the gray, or for overhangs like this bridge that just look a little off without anything. Then finally, there's the trees, which is really the piece de resistance. The result is a not too shabby mountain with enough character to please the observing eye. For the remainder of the table, I just mashed the outline of a road and painted it in. I did also test the mountain with the RC excavator, and it was able to climb it. While I was working on the table, I thought of a couple more features I wanted to add to the log truck. In total, I've gone through about 5 or 6 iterations on the self-loader alone, each iteration adding a little more functionality. A feature I debated for a while on how to add was a way to lock the pup in place when it's tailing behind the truck. When it's unloaded and I drive forward and backward, it slides all the way from the front to the back of the reach, which admittedly doesn't look or sound the best. At first, my plan was to use a servo inside the pup that could clamp down on the reach and lock it in place. But before going down that road, I wanted to see if I could come up with a way to lock the pup in place using the loader arm and eliminate a motor as well as a set of wires running from the truck to the pup. After all, this loader arm is basically a full-on robotic arm, so I should be able to come up with something. That's where these rectangular cutouts on the reach come in, which are responsible for allowing this free swinging clip to nestle down and lock the pup in place so it doesn't move back and forth. Using the loader arm, you can reach over and either flip the clip up and out of the way or down and into place. Pretty slick if I do say so myself. With the table now finished and all the key features addressed, I can finally take this for its first real test run, in which I'll be practicing unloading and loading more dowels. Unloading went really well, though I still need to add a heel to the dipper, which should help stabilize the log while lifting. For example, when I pick up a dowel not perfectly in the middle, the dowel tips towards whichever side has more weight, making it hard to lift up over the bunks. A heel in place will stop the dowel at a certain point and keep it semi-flat. With all the dowels unloaded, I flipped the clip up on the pup and proceeded to drag it up onto the back of the truck. As you can see, it did not happen seamlessly, meaning I've still got some more work to do in figuring out the perfect reach length so that it folds smoothly. In addition, you can see as I bring the arm in and down, the grapple is actually getting in the way and I'm having to walk it down using rotation. At which point I'm never able to get the arm perfectly parallel with the top of the truck, which will also need to be addressed. Taking the truck around the block and then back to the landing area, I again ran into some issues with unfolding the pup from the truck, but still confident I'll be able to tweak all the angles to make it happen smoothly. These dowels are actually rather heavy, so lifting these up into the bunks is about at the max of what I would try to load. The grapple rotation is absolutely essential in making this possible, as it really allows you to wiggle a log into place or settle other logs if necessary before taking off. Driving around with the logs loaded brings me to today's physics lesson. On a log truck setup like this, once the logs are loaded, they actually end up forming part, if not most, of the trailer's rigidity/structure. Essentially, with the logs pinched in place by the front and rear bunks, they become the frame of the trailer, which causes problems because the reach of the pup doesn't pivot at the front bunk. No, it pivots way out here in the middle of the bunks. What this means is that when I go into a turn, everything binds up. This is because the distance between the bunks wants to stay the same due to the fact that they're bound together by these straight logs. Without the logs though, when I make that same left turn and nothing is impeded by the logs, the bunks actually move closer together because the reach is pivoting in the middle. As you see in this animation, the distance gets smaller the harder I turn the truck. Now this causes a massive problem because with the logs loaded, that distance can't really get smaller or bigger anymore, which means when you turn into a hard left turn, everything ends up binding up and doing weird things. The logs are trying to keep everything straight, but the rear pup needs to move closer to achieve a turning angle with the truck. This exact thing was what my brother tried to warn me about when I first started this project, and I shrugged it off thinking something like that wouldn't affect my small model. Luckily, in the real world, there's a component that solves all of these problems. It's called a compensator. Its job is to purely allow the reach to get shorter and longer when turning, allowing the rear pup to still achieve the proper turning angle without violating any physics length laws. I thought long and hard on how to achieve this on my model and came up with ideas like a motor that moves in and out with the truck. But then it hit me. Literally the simplest and most effective solution is to just unclip the latch. That's it, just unclip the latch and allow the pup to move back and forth on the existing length of reach. That's basically what the real life version does. This actually worked, and to show you just how much it compensates, look at this clip where I reverse into a turn and then pull forward. That's almost 3 inches of travel, but now I'm able to turn the truck and reverse the pup without anything binding up. I'm still opting to leave the clip and groove system in place because it's a cool feature that gives you the option to pull the pup behind the truck without having to load it every time there's no logs. To fully optimize the loading procedure, I went through about 6 different reach to stinger ratios so as to give the pup a long enough section to slide around on, as well as a shortened truck folding section, aka stinger, to make pulling it up onto the back super easy, as well as unloading it super smooth. Next, I went in for my last iteration on the arm, with the goal being to fully optimize motor placements to increase torque at the most usable point. For the main boom, the most power is required around this 110 to 160 degree range. This is where I find myself using it to lift logs up into place. So in order to optimize the amount of lifting power I have in this range, I basically try to place everything so that the push rod covers the most distance on the threaded rod inside this range. The reason for that is the more distance the push rod covers on the threaded rod in that range means more revolutions of the motor have taken place. In simple terms, it can stretch that heavy lifting over a longer period of time. It's the same idea as me moving 10, 20-pound blocks over the course of 10 minutes versus me trying to move a 200-pound block in 1 minute. One takes a lot more upfront power. At this point, I've pretty much just got cosmetic stuff left, the first being mud flaps, which after seeing how much cooler it made my side dump look, I of course put logos on them as well. You seriously just can't go wrong adding these. They add so much to the model, and you can of course customize them with your own logo, such as this fine individual who uploaded a remix with a different logo on printables. Also, I want to take a brief moment to shout out this slide off truck that was uploaded to printables. This thing is awesome. Next, I sketched out a headache rack and printed it out. Now, not only is our dummy 13 Santa Claus man who's driving the truck slightly safer when he slams on the brakes and a log comes flying forward at Mach 10 at his head, his ride also just looks a little cooler. I would love it if someone designed some small 3D printed shovels and straps as a remix for this so we could strap it on the back. Next, I also deemed it time to ditch this golden brown color. While I think it's nice, I've been eyeing up this blue silk PLA for some time now. It was actually pretty easy to print as the parts came out absolutely beautiful. And I especially like the look of it with a logo extruded in on the door using a secondary color. I transferred all the silver parts from the golden cab to this one and then placed everything back onto the truck frame. The results, well, I think the results speak for themselves. To put this whole log truck idea to the test, I first need to ditch these dowels as they just don't scratch that mini log look. Instead, I gathered up some dead sticks and broke them up into pieces. These immediately improved the overall look of the truck, and because they're slightly smaller, I can grab multiple at a time. I then proceeded to place them on top of my diorama mountain, thinking it'd be a fun challenge to drive the truck up and haul them away. It wasn't. At first, I just tried gassing it up the hill at max speed, but to no avail. Then I tried swapping from TPU tires to these silicone printed tires, which helped me get to the top, but ultimately wasn't the ticket as the road up to the top is so bumpy and steep, the pup just got yeeted right off the back, and I still had to figure out how to turn around. Then the great idea to try reversing up the mountain hit me, which had potential, but my front bumper kept getting hung up, so I did the only reasonable thing to do: chop half of it off.
Let me see your war face.
This made a huge difference, and I was finally able to Hail Mary my way to the top and make Tow Mater himself proud.
Yes! Yes!
I then faced the challenge of getting the truck turned around enough to unload the pup and put enough room between it and the truck to load logs. The arm was clutch for this, as I used it to push off of walls, push off the ground, and at one point I even used it to push and pull off a tree. With everything finally in position, I did the only thing that went smoothly on this whole journey, which was load the logs. Coming down the mountain, well, I ended up having to load the logs twice. I did get everything transported across an astounding 10 feet of space to the other side of the table in the end, and never have I ever felt so proud for achieving such a minuscule amount of work. Oh, and my only casualties were a tire blowout and that I also filmed that whole thing without my mud flaps on. You are able to wire the rear taillights up on both the truck and pup. I found that doing 2 decent sized loops around the reach for the light wires is sufficient for it still being able to extend and retract fully. Converting the truck to still have the arm, but also the 5th wheel hitching mechanism in place is actually super straightforward. I just removed the pup and bunks, then put everything I initially tore out back in. What was a little tricky was putting all the trailer specific code back in, as my idea of wiping all of that out initially backfired hard in a slightly annoying way. Nevertheless, I did get it all set up so that you can hitch to either the drop deck trailer or side dump, send all the power and commands like normal to the trailer, but then also switch into loader mode and carry out any needed tasks. The only downside of this is the placement of the loader arm, which can interfere with the front of the trailers. To solve this, I've made a modified version of the front deck on the drop deck trailer with tapered corners, which I'll have available in the 3D files for this model. But now you can haul and drive it around like normal, and when the need arises, use the loader arm to hoist stuff up onto it. To really give you an idea of what's possible with this setup, I sat down in my favorite living room chair and proceeded to clean my living room using the truck. Furthermore, if you're looking to make that morning coffee just a little bit more productive, then look no further, because picking sticks up by hand is so last century when you've got an RC semi with a robotic arm on the back. I've got one last thing to do before calling it a day on this log truck, which is to build one more just to be sure I have all the assembly steps as straightforward and easy to follow as possible. While doing this, I also took the opportunity to build out a custom one-of-one truck for my brother, as it's not every day your YouTube channel and your brother's job perfectly align. I went with this cherry red silk PLA to match his real life truck, but there will always be the difference in that his truck isn't a self-loader. I found that these Harbor Freight cases make for the perfect delivery system, as they protect the model you've just spent hours building from any falls, and they do it in style. For real. Isn't this the coolest looking present you've ever seen? It just feels so official. I then left my office, threw it in the car, drove 2 hours, took it back out of the car, and delivered it to this gem of a human. Upon arrival, I verified he was actually certified to be operating such a model. Then he of course took it for a little spin. Also bro, if you're watching this, that counts as your Christmas and birthday present. So to get your hands on one of these RC log trucks, or really any of these RC models, you can by joining the Professor Boots workshop on my website, professorboots.com. which gives you step-by-step guides to every single project I've done these last 2 years. The guides include information on 3D printing all the parts, sourcing the electronics, uploading the code, and everything else that goes into building one of these. So consider checking it out, as it helps support this channel a ton, as well as the development of future projects like this one. Now here comes the fun part. Just like with all of the previous projects, you, the community, get to help pick the next build. So please comment down below what piece of equipment you'd like to see next. It could be a front loader, dozer, backhoe, etc. Whatever piece of equipment gets the most comments and support will be the next project. With that, thank you all so much for watching, and I'll see you here soon with another project.